Okay, welcome to my 3D programming language explanation of loops. Okay, so here I have made several examples. Let's start with for loops. Okay, let's make the code big. Let's see, so here we have, I started off teaching how to do it in Scratch. Let me explain some things. There is no repeat statement in 3DPL. Instead, we have loops. It is possible to create a repeat statement, but that is not in the scope of this tutorial. So we have for loops. Let's see. A for loop is done in this way. So we have for a variable is equal to the start value, and then it's that variable less than, I think I made a mistake there, but less than a value, and then, well, let me tell you what each part is. In this part, we call it the where we initialize the variable. We set the variable to its initial value. This one is called the condition. So the loop will repeat while this condition is true. And then this one is called the incrementer. So in this case, when it's plus plus, it's an incrementer. A plus plus means A equals A plus 1. So it's the same thing. So basically here we're saying, okay, A equals 0, and 0 would be the center of the screen where the blue cube starts. Let me make this small again. Okay, so if I change this 0 to 1, let's say 2, you will see that the blue cubes have decreased. So I'll set it back to 0. So that's the starting position of our cubes. Then the end position. Let me change this back to 4. Yeah. Okay, so in 3DPL, like in most other programming languages, we count from 0. So we're saying when 0 is, well, A is less than 4, and it will be less than 4, which means 0, 1, 2, 3. It will count up to 3. Then A++ tells it to make A more and more each time the loop iterates, or it goes through the loop. Okay. Then let me make the code window big again. Every time the loop, this is the body of the loop, where when the loop loops, it creates a cube each time. Each one of the cubes is called blue cube. And then the position is A. So the first position, the first time it iterates, is at 0, then 1, 2, and 3. And that creates this nice blue bar, 0, 1, 2, and 3. Okay? 3. So we have 4 cubes that are blue. Then this code just makes the cubes blue. Then let's take a look at our other. By the way, when you might, I haven't covered this in this tutorial, but sometimes you want to go from a higher number to a lower number. So we could say A equals 7, and A is more than 0, and then say A minus minus, and that would go the other way around. But I'm not going to cover that in this tutorial. Okay. Then let's take a look. This is pretty much the same for loop, except with the variable B, and it makes green cubes. The only difference is that when I generate the cubes, I'm increasing both the x-axis and the y-axis. And since I'm coloring these cubes green, they start going like in a diagonal line. Let's see. So we have b equals 2. So when I'm starting from the number 2, you don't have to start from 0. And then it counts up to 5. So 2, 3, 4, 5. That's why we have 3 cubes. 2, 3, 4. And when it gets to 5, the loop ends. Because this condition becomes false. This condition becomes false when b is equal to 5. Okay, so that's it for for loops. Let's go for the next one. Let's go for nested loops. Okay, so a nested loop, in this case, nested loops can be any kind of loop that's nested, a loop inside a loop. In this case, I'm nesting 2 for loops. I'm saying, okay, start the x variable to count from 0 to 4, and then start the y variable to start from 0 to 3, and then I'm telling it to draw each cube at x and y axis. So we should have, let me change this 4 to 3 so that it's more clear what we're doing. Okay, so we have 1, 2, 3 in the y-axis and 1, 2, 3, 4, 5 cubes in the x-axis. And that's about it. That's what nested loops can be used for making a big cube of cubes in this case. Let me load the next example. What was the next one I was going to explain? Well, let's go for the eternal loops. Yes, remember the forever loop we made in Scratch? Well, in this case, in 3DPL and in most other languages, while true or while one will both be the same as saying forever. The reason why in C while 1 is the same as while true is because the number 1 is considered to be true. Anything that's not 0 is considered to be true. So, well, here I'm using the special variables of 3DPL, which I didn't really have to use, but I thought I'd introduce them. They're pretty much the same. So this says variable A is equal to 0. While true, so this is an eternal loop. In normal circumstances, if we don't break out of the loop, where here's the break statement, this loop will continue forever. Now, 3DPL has functionality in the declarations part of it, not in the update yet. I will be working on that. In the declaration part, you can declare an eternal loop, and since it's a real-time interpreted language, you would think it would freeze the program if you made an eternal loop. But actually, there is something hidden in the language which helps prevent that. You can make an eternal loop, but it most probably won't freeze the program. It will give a timeout, and then it will give you back control of your computer. Okay, so then we have vars equals vars plus 1. I mean, A equals A plus 1. Then if A equals 4, break. So we're saying whenever A reaches the value 4, break. Break means get out of the while loop. Then else is the other condition of the if statement. Draw a cube with the x-axis being A. And that is, yeah, we have 1, 2, 3. We have 3 cubes because we're counting from 0 to 4, and that's why we have this bar of 3 cubes. Now let's go to the last example. Which one is it? Do until loops. Now the output of this is pretty much the same. It's just a little bit longer bar. So here I'm setting a equals 0, and the difference between a while loop and a do while loop, or what is known sometimes as do until in other languages like Visual Basic. A do while loop, the condition is checked at the end of the loop. So when you have a do while loop, the body of the loop will at least execute one time. So here we're saying a equals a plus 1, so we're incrementing a. Then we're drawing the cubes, and now notice that we're actually here we're checking to see whether a is not equal to 4, and so the loop continues while a is not equal to 4. So basically it goes from 0 to 3. So let's see, 0. Let me make it a little bit smaller so that we can actually see the result. Instead of 4, let's make it 3. Okay. So now it's going from 0 to 2. Yeah, 0 to 2. So this is 0, 1, 2. So that's why we have 3 cubes. Okay. And that's pretty much it for my example of loops. I guess the thing I left out is the stepping loop that goes backwards from a larger number to a lower number. Maybe I'll cover that in another tutorial. Okay, bye for now.